In cardiac MRI, we use balanced steady-state free precession multiphase sequences to assess wall motion throughout the cardiac cycle and also valve function. An important parameter here is temporal resolution. Effective temporal resolution is computed by taking the RR interval, in this case roughly 1000 milliseconds, and dividing it by the number of cardiac phases we want to reconstruct, which in our case is 20 phases. That gives us a temporal resolution of 50 milliseconds. Now, in our acquisitions, there is a real temporal resolution, which comes from the views per segment parameter. Views per segment determines how data is collected and filled in case space. It's the actual number of case space lines filled per slice per heartbeat. Real temporal resolution comes from multiplying views per segment times the repetition time. In this case, that gives us 10.8 milliseconds. The Society for Cardiovascular Magnetic Resonance recommends that acquisitions should have a real temporal resolution of less than 40 milliseconds. Now, views per segment also impacts acquisition time. The higher the views per segment, the lower the temporal resolution, and the shorter the acquisition time. In this example, where we have one single slice using one excitation, we can calculate the acquisition time by taking the number of phase encoding steps, 192, and dividing by our views per segment. That gives us an acquisition time of 48 seconds. It's important that we optimize this acquisition time to match the patient's breath hold capability. To speed up the scan, we typically use parallel imaging. If we use SENSE with an acceleration factor of 2, that reduces acquisition time to half. So remember, views per segment lets us optimize temporal resolution, and using parallel imaging, we can achieve acquisition times that are reproducible for breath hold timings across patients while maintaining high image quality.